Welcome to session 2 as we prepare for our prelim exam. And in this, we're trying to look at 3 concepts: electrochemistry, acid and base, and chemical equilibrium. It's going to be quite a heavy session as these topics are, the big boss when it comes to paper 2. Electrochemistry being the easiest though, quite long. So I'm going to quickly do a crash course like we normally do and summarize everything you need to know when it comes to electrochemistry. Okay, so let's divide the board into 2 quickly. All right, so if I talk about electrochemistry, what are the important things that I need to know? Electrochem. All right, so let's have a checklist. Number 1, can we define? Definition. And what are we defining? Oxidation and reduction. I'm sure you all have a song that talks about redox, where we define oxidation is the loss of electron and reduction is the gain of electron. Oxidation is an increase in oxidation number and reduction is a decrease. Everyone should have the song by now. All right, so you should be able to define in terms of electron and you should be able to define in terms of oxidation number. That's number 1 definition. Number 2 definition, remember, it's just a crash course. I'm sure you know that. Number 2 definition is to be able to define electrochemical cells. What are your electrochemical cells? There are 2 of them. We'll talk about galvanic and electrolytic. So what is a galvanic cell? It's a cell that converts what? Chemical energy to electrical that you cannot miss out. All right. And electrolytic, how would you remember? I look at what I'm starting with, elect. So I'm talking about electricity. All right. That's a key. Electrical energy converted to chemical energy. Okay, this reaction is not spontaneous. Hence, we need a power supply. It is not spontaneous. This one is spontaneous. Guys, when it is not spontaneous, we need a DC power supply. And if you've been with me, I think I've explained why we need a DC. A DC because we want to maintain polarity. We're going to talk about it as we go on. We want to maintain polarity. So the first thing is to be able to define oxidation and reduction. The second thing is to know your electrochemical cells. There are other definitions we would go across. We would answer them as we come across them while we're answering questions. Is that okay? But basically, please know this. The third one is to be able to define electrolysis itself and be able to define an electrolyte. Okay, so these are the basic definitions. We will define as we come across, as I'm trying to just do a crash course. Guys, in this topic, what is key in answering and understanding electrochemical reactions is to understand redox itself. And when I say redox, you need to understand what is oxidized and what is reduced. Okay. Now the question is, what is oxidized and what is reduced? Something that is oxidized is called a reducing agent. And it is a substance that loses electron. Because we talk about oxidation being the loss. So a reducing agent is a substance that loses electron. All right? And what is reduced? Reduced is an oxidizing agent. And this is a substance that gains electron. So the idea here is to identify, which would be the crop of what I'm going to do. After that, we answer questions. Is to, if you can identify what is oxidized and what is reduced, you are okay with the topic. The rest just is interpreting what is the product. So how do we identify what is oxidized and what is reduced? That's the core. And if I say what is oxidized and what is reduced, we're just going to look at the anode and the cathode. At the anode, oxidation, and at the cathode, reduction. I'm sure you know all of this, guys, but just laying a foundation. I'm just saying I'm starting all over. What would I do? Number one, anode. That is where we have the loss of electron. Here, what do we have? The gain of electron. Okay, that's number one. Number two, the anode will decrease. Okay, before I go to that, increase in oxidation. That's what happens at the anode. Oxidation number, because that's where oxidation takes place. So the substance there will increase oxidation number. While here, there is a decrease in oxidation number. Number three, anode will decrease in size. The cathode will increase in size. Number four, I'm sure you remember all the little tricks. All the little tricks that I spoke about. Okay. Number four, ape. Use the word ape. Anode is positive in the electrolytic. Oh, if it's positive in the electrolytic, it is therefore negative. Negative, you know that, negative. Negative in the electrolytic. So I'm using the word ape. Number five. The anode is negative in the galvanic. And the anode, the cathode rather, is positive. All you need to do is to get one right. Get this one right. The rest will just fall into place. Positive in the galvanic. Once you can remember the word ape, you just flip it. All right, anode is positive in the electrolytic, therefore it's negative in the galvanic. So if anode is positive in the electrolytic, all right, it's then negative in the galvanic. And then the other one would be the opposite. Okay. Guys, how can you say someone is pregnant at the neck? I don't know who taught you that. It's not me, though. It's not me. It's not me. Okay. Number 6. Guys, let me teach you something today. Number 6. Now, these are cheats now. You can use your number line. Okay? Guys, if I draw a number line, let's use a number line. It's 0 there. It's negative there. It's positive, right? It is always the anode before the cathode. Anode and the cathode. We're talking about the E values. If you check your table, this is what I'm talking about. The more negative a substance is, it becomes the anode. The more positive a substance is, it becomes the cathode. Or let me draw this in the middle. So we are using our number line to actually find out. The reason I'm showing you this number line is sometimes an examiner would give you X and Y. And there's no X and Y on your table. Okay, negative there and positive. We always start from A. So the more negative a substance is, it will be at the anode. The more positive a substance is, it will be at the cathode. The A and C. I'm not political, guys. Okay, I'm not political. Number 7 is to use the table. If you remember all of this, you're good. Number 7 is to use the table. Again, it is A and C and President Jacob Zuma. Zuma is not that bad, guys. At least he's teaching us electrochemistry. It's the first scientific president that I know. Okay. And I'm sure, guys, you know how that works. We're going to look at that, how that works. Okay. Yes. Zuma ain't that bad. He's my colleague when it comes to electrochemistry. We roll together, you know. Just I couldn't follow him to where he was going. But he's my colleague. He's my buddy. All right, guys. Look, this is important. Take a screenshot and post. Stick a screenshot quickly and just post on your status. Electrochemistry simplified. If you know what's going on here, you are done. Like the Gulabs will say, boom. No, I didn't want to follow him. If I follow him, guys, I won't be here teaching you. All right. Now, so we have these 7 ways. All right. A perfect number. 7 ways of identifying your anode and the cathode. 7 ways of identifying your anode and cathode. Leica, let me get this diagram right this time. Where is Sophie? Okay, now where's the stomach? Guys, I don't know. With my, you here? You're too quiet for me. You didn't even say hello. This child. Hi. I'm okay. All right. No, don't worry. I'm going to go through the Z thing when I want to answer a question. Okay. I said examiner would give you things like X and Y, and they give you values. For example, an examiner comes and say the E value of X is negative 2,3 volts, and the E value of Y is negative 3,1 volts. You cannot go look for X and Y on the table. They're not there. So the question is, which one would be the anode and which one would be the cathode? Guys, let's try this. Which one is my anode? Is it X or Y? Leica, please leave me alone. She's now pregnant by the M. Of course, her hand is on the stomach. Great. We're getting it. It's Y. Because Y is more negative. All right. So Y is far here. And X would be somewhere there. So Y becomes the anode and X becomes the cathode. Well done, guys. Well done. Well done. Lovely. This is great. This is great. Okay. So once we have identified, I'm going to go to number 7 now to guide us through the rest. Okay. Yay. That's Brown saying yay. Okay. Now let's go to number 7 and use number 7 to answer a few things. Everybody okay? Where's Anele? Is she in the house? Nele? Anele. Oh, by the way, guys, when I'm talking about the table, we are going to use 4B to walk around this A and C. Is that okay? 4B to walk around the A and C. Yes, okay, I love this question. Lonel says, sir, but why? The anode is positive in electrolytic. Now, that is talking about the polarity. Here, we are talking about the E value, all right, which is measured by your standard hydrogen electrode. I'm going to prove it to you just now, Lonel. Just follow me. All right, follow like Twitter. Okay? Just follow like Twitter. Okay, guys, Anela is not in the house. I wonder where she is. So we use 4B to deal with President Jacob Zuma, ex-president, my friend, Jacob Zuma. Okay, now, when we get to that 4B table, guys, the 4B table, we said it is A, N, and C. Okay? And if we write Z, it's like that. How does this then work? Okay, 4B table. Guys, the first one you find will be on top, and the second one would be below. Let's try something quickly. Let's look at aluminium and silver, for example. Aluminium and silver. You don't need to stress. Just go to your table. We're dealing with aluminium and silver. I'm going to do a number of things here. Aluminium and silver. Please, everyone, go to your 4B table. I want to believe you have a table. And tell me the one you find first on 4B. Is it aluminium or is it silver?
Aluminium.
Are you sure, Nonguleko,
Yes.
that your table is not from China?
I'm very sure.
Do we all agree with Nonguleko? AL. Okay, thank you so much, guys. Nangu? You know I trust you, my child. You know that.
I wanted the one who's talking to
Okay. All right, AL. So, guys, we have AL first. Look at what I'm going to do. The reaction that I have is Al3 plus 3E. That's what I have on the table, right? To give me Al. I'm just copying that here. Once you understand this, you don't need to copy it. You can draw the Z on your table. All right? Ag plus E. This is what I have. Okay. Now look at, I have identified what's the anode and the cathode. The first thing is to write my half reactions. Half reaction at the anode. Look at what Jacob Zuma is telling us to do. I hope I won't be arrested, but it's a good thing, to name a system after a president. It's a good thing. Now, the arrow says we are moving in that direction. Do you see that arrow? We start from the right, going to the left. We start from the right, going. Kate Bonnie, which table are you using? Please, it's 4B. 4B. Okay, you saw your mistake. Okay, so 4B. In fact, when you get to the exam and they give you a paper, just cancel 4A. So when you get there tomorrow and you're writing your paper, once you see 4A, once they say start writing, this is what you do. Although this is my 4B, but just take a pencil and do that. Scratch it out. Scratch 4A out completely. Don't use it. Okay. So that you're not confused. You use only 4B. B for bishop. Remember that. You use the bishop's table. Your tutor. Okay. Anode. Now, we start from the right, going to the left. So what am I going to write for the half reaction at the anode? What's on the left? It is aluminum solid. Okay. My arrow should be a single one. What's on the right? Al3 plus, which is aqueous, plus 3 electrons. And I'm done. It's 2 marks. It's 2 marks. Yes, Tamron. It's B for bishop. So you use the bishop's table. Can we write the cathode? And remember what takes place at the cathode? I'll show you ways again to remember. We start from the left. This time the arrow says we go to the right. Ag plus E to give us Ag. Here there's nothing there, it's a solid. If there's a plus here, it's an aqueous. Guys, for each of these reactions, when you are asked, it's 2 marks. Everybody okay? Everybody okay here? Half reactions? Everybody okay? It's a +2. Because automatically +2. Okay, I'm getting a lot of okays. Thank you so much. And for those that did not answer me, thank you too for not responding. You are welcome. Lesero, use the arrows to guide yourself. Okay. The arrow at the top says start from the right, going to the left. So you write what's at the right first. Yes, those who did not say thank you too for not saying okay. We appreciate you for your silence. The arrow says start from the right. So it's the right to the left. That's what the arrow says. That's why I have Al first, then Al3 plus second. Please make sure that these are single arrows. Once you write a double arrow, you lose 1 mark. All right. Okay. And then this one we start from the left, going to the right. Are we okay now, Lesejo? Whoo, here she comes. She's in now. She's in. She's in. That child is in. Number 2. All right. Are we okay, guys? Number 2 now is to write your net ionic equation. Net ion. Like your pleasure. Your pleasure for what? All right. Number 2. Net ionic. Gulabs, I hope Ningi is okay. It's been a while. Net ionic equation. The net ionic equation, guys, is that you add the 2 together. All right, net means total. You add after balancing the electrons. You add after balancing the electrons. Okay, Laika, for your silence. All right. Lovely. Now, guys, if you look at equation, we can basically call this equation 1 and equation 2. How do I balance? Let me write it here so that we don't have ourselves confused. Okay, and what do I have here? Silver plus. All right. You would see that the electrons are not balanced. What I'm going to do is I'm going to multiply this one by 1. Somebody saying, where's the 1 coming from? The 1 is coming from this electron. And I'm going to multiply this one by 3. Somebody say, where's the 3 coming from? I'm just switching. I hope you see. Multiply the top by the number of the electrons at the bottom. Multiply the bottom by the number of electrons at the top. So that at the end of the day, I have the same number of electrons. This is basically elimination method of simultaneous equation. Al3 plus 3E because I'm multiplying by 1. This gives me 3Ag plus 3 electrons to give me 3Ag. Now you add. Once the electrons are now balanced, 3 there, 3 there, 3 there. Oh, it's now balanced. Great. All I need to do is to write Al plus 3Ag plus everything on the left to the left. Arrow. What's on the right? Al3 plus 3Ag. This is a solid. That is an aqueous. That is an aqueous. And that is a solid. It's 3 marks here, guys. It is 3 marks there. I hope it's okay. We're moving fast. Net ionic equation. Everybody good? The last step is to write what's on the left. Everything that's on the left after balancing. Al is on the left. It comes here. 3Ag plus is on the left. It stays to the left. Then I go to the right. Al3 plus on the right. 3Ag on the right. It's another way of balancing equations. The electrons cancel out. Glab. If I were to write my electrons, look at what I will have written. Writing everything on the left. Mathematics now. Check. I will have written this. Al plus 3Ag plus 3 electrons to give me Al3 plus 3Ag plus 3 electrons. Do you see 3 electrons? Mathematically, if I move this over mathematically, we say it's negative, right? It cancels out. So there's no need to waste your time to write it. Once you have balanced, just write, simplify, write what's on the left, the species on the left to the left, the species on the right to the right. Everybody okay? Tandiswa, you got it? Thank you, Gulabs. Everybody, I think everybody should be fine now. These are the simple things, the 1, 2, 3 marks that you need to get as fast as possible. Awesome. Okay, great. The next thing again is to write your cell notation. Your cell notation. And your cell notation, we say it's as simple as ABC. Cell notation is as simple as A, B, C. All right, cell notation. And the cell notation is only written for the galvanic cell. It's only for the galvanic cell. It's as simple as A, B, C. You start with the anode, then you write the salt bridge, and then you write the cathode. I'm going to do salt bridge just after now. It's as simple as A, B, C. Yes, Brown, it is so easy. It is so easy. Now, what you need to write at the anode is your half cell again. Look at what I'm going to write. What do I have at the anode? It's Al. I'm going to start with Al, solid. Then I go to Al3 plus. Al3 plus. That's my anode. And this is aqueous. How do I represent the salt bridge? A double line. Then I go to my cathode. What do I have at the cathode? Ag. Guys, do you see that everything rests on you identifying what is oxidized and what is reduced? All right? And then what do I have? Ag, solid. Something is wrong with my write-up though. What is wrong? This is a solid phase, that's an aqueous phase. We put a single stroke there to represent phase change. Take note of that. That is called a phase change or a phase separator. It separates the phases. Should I have the same phase? Then I don't need a phase separator. I hope I find an example that will help us. And what is this? That is a salt what? Bridge. While I'm here, I know I'm compressing the whole thing. It's a revision, so I'm compressing it. While I'm here, we can talk about standard conditions. And the standard conditions, you don't need to cram it, guys. Standard conditions of a galvanic cell. Here, it is 298 Kelvin, or what you call 25 degrees Celsius. This value is actually on your table. If you have a formula page, please go and check kW of water. Everybody, look for kW of water. I hope I have one here. A full formula page. Oh no, I don't have. I don't have one. How come? But please go and check where you have kW of water. You would see there's a temperature by that side. Let me know if you found it. kW of water. Let me know if you found it. Good. Sophie, you don't write the coefficient of the balanced. Okay? Please don't write it. All right. I'm glad. Guys, you're finding it, right? That's where you check if they ask for the standard temperature. Sophie, you got me? Sophie has asked a very lovely question. Don't we write the coefficient of the balanced when writing the cell notation? And the answer is no. Check where you have your acid and base calculation. Yes. Where you have 1 times 10 to the power negative 14, there is a temperature by the side there. I don't have one here. Let me crop one here for you to see. Let me crop one quickly for you to see so that we are all on the same page. But if you have found it, let me know. All right, Uncle Leko got it. Sophie, have you found it? All right, so that's your formula page. And that's what I'm talking about. 298 Kelvin. Yes, so you guys don't need to cram it. Just go to your formula page and copy. Okay, 298 Kelvin. That is number 1. Number 2, the second standard condition, it is standard temperature, concentration, and pressure. The second one is standard pressure. Again, I don't want you to cram it. The standard pressure, let's go back to our formula page, is the first thing you see on your formula page. Do you see standard pressure there? It is the first thing you see. 1,013 times 10 to the power 5 Pascal. That is your standard pressure. Somebody's going to say, why are we not using 273 as standard temperature? Please understand that 273 is how you convert Celsius to Kelvin. Okay. All right? Is how you convert Celsius to Kelvin. But the standard temperature for a galvanic cell is the one below. Please take note of that. Sophie, I'm going to answer your question. All right? Now, standard pressure is 1,01 times 10 to the power negative 5, or what you call 1 atmosphere. There's no need to cram it. Just go to your formula page. Guys, please understand, it is your right to copy. It is your student scientific right to copy. Copyright reserved. We have reserved the right for you to copy from the formula page. Okay. All right. So please let's take note. Copy. So standard temperature is either you write 1 atm, 1 atmosphere, or you write the value on the table there. And this is only applicable. You only write this when we have a gas in the mix. All right. When you have a gas in the mix. And finally, standard concentration. I'm telling you guys, it is your right to copy. Standard concentration of 1 mole per dm cube. That's our standard concentration. So please take note of the 3. Standard pressure for gases. Don't write a pressure when there is no gas. And that will lead me to answer Sophie's question. You don't write a pressure when there is no gas. And to answer Sophie's question, I'm going to use a particular question that I see. All right. So let's quickly talk about salt bridge and we're done. Then I'll do a crash course on electrolytic too. Salt bridge. Salt bridge. Number 1 function is to complete the circuit. And number 2 function is to maintain Nonkuleko, when do we use what? I'm lost with what you're telling me.
For the standard temperature things, pressure, yeah.
They'll ask you to write the standard conditions.
Okay.
Yes, Nana? All right. Number 2 is to maintain electrical neutrality. All right, in the half cells. And how will that happen? Guys, throughout electrochemistry, one thing will always happen. The anions will always move to the anode throughout electrochemistry. And the cations will move to the cathode. I hope you know what cations are. Listen to the song. It's about 2 reactions, anions and cations. You remember that song? Popping from side to side. Okay? Anions and negative ions. Ooh, idols, I'm coming. Anions are negative and cations are positive. Anions will always move to the anode and cations will move to the cathode. Sophie, when I win that money, I'm going to deny knowing you. Don't worry. Okay. Now, the salt bridge contains an inert electrolyte. Okay, let me say inert ionic solution, better word. And when I say ionic, it means it has cations and anions. Is that okay? Cations and anions. Kaylee, wooden mic. At least it's a mic. Nonkuleko, I'm going to chase you out of my class. All right. Contains inert ionic solution. That's why we say anions and cations. Meanwhile, Nonkuleko does not even know how to sing. Good, Katia. That song must play in your head. I have one that I'm doing right now, applications. I hope I'll be able to finish today. Otherwise, you'll use it for finals. Anyway, guys, it contains inert ionic solution. Is that okay? Now, let's answer a question. I want to see what we can do, Let's answer one question on galvanic quickly. Here we go. Please follow through. We're not losing any mark here. I promise you that. No mark will be lost here. Okay. And I want us to, just before we even look at the questions, I want us to explore. Lovely. The cell notation of a standard galvanic cell. All right, I will send it. Laika would give me a golden buzzer. You are such a sweetheart. Right now, I'm blushing and I'm melting. And, tears, Laika. Thank you for the buzzer. I can't even talk anymore. All right, let's answer the following questions. Okay. Now, the cell notation of a standard galvanic cell. Now, they told us that it is a cell notation. Remember, cell notation is as simple as A, B, and C. I'm glad we just looked at that. Oh, what do you see here? This is the anode, that is the salt bridge, and that is the cathode. What happens at the cathode? Oxidation. And what happens at the anode? Reduction. And you would see it is oxidation. There's a 0 here. 0 to positive 2. Increase. Positive 2 to 0. Decrease. That's the first thing I can actually pick from here. Okay? Now, let's check this. So we know our anode. Here is the anode. I'm going to do a lot of things here now. Please take note. That is the anode. So this is the way this examiner decides to tell us what the anode is. Some examiners would do this. They would tell you the flow of electrons. They do that. Electrons would flow from anode to the cathode. I thought of something today. I was in a school and in my head, you know what played in my head? It's a cartoon kind of thing. Check this. And I'm going to do the animation very soon. You would see. And I'm glad I'm saying it now before people say it's their story. Check this. Alphabetically. Let's rearrange. Okay, we have an electron, right? An electron wants to go to its position. Look at what it will do. It will pass through the anode first. So it jumps on A, then jumps on B, then jumps on C. It will get to the anode and move to the cathode. So electrons will flow from A to C in trying to go back to its original alphabetic position E. I don't know if it makes sense. Let me show you something. I know you're going to say I want to do something amazing. Let me show you something. Did that make sense, guys? Arrange it alphabetically. E would jump dong, 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 dong. A to C. The anode will first move from, the electron will move from the anode to the cathode. Beautiful. So these are things just to have fun. All right, let's have fun. It's crazy physics, by the way. Okay, I'm glad it makes sense. Anode will decrease in size. I think we did a question like that some time ago. While the cathode will increase in size. What else? Now, remember, GAN. Even if you don't remember that, if you remember ape, okay, I used to say G strings are nice on apes. The galvanic anode is negative. So another examiner would do this for you, minus and plus. They will do that again. Take note. Anode is negative in the galvanic. Don't cram it. Just remember that G strings are nice on apes. Okay. So these are the different ways an examiner would want to let you know which one is the anode and which one is the cathode. And in the salt bridge, anions will move to the anode. And cations would move to the cathode. So I have cations here moving. And I have anions moving. All right. Now, let's answer questions. Ooh, I'm glad we were here. Guys, what is this V? What is this? Somebody wants to tell me what that V is? It's not Victoria, please. Can somebody tell me what V stands for there? All right. It's a voltmeter. Okay. Let's answer the questions now. Let's answer the following questions. All right. Voltmeter. Thank you, guys. You guys are the smartest thing that I've ever seen. In terms of human and aliens, you are the smartest. You are the I wish I was as smart as you. All right, let's answer the questions. 9.1.1. Name the component of the cell that is represented by the double vertical lines in the cell notation. Talk to me. No quiz on fire. She's burning up. She's burning up. This girl is on fire. She's burning up, burning up. Doo, doo, doo. Thank you, guys. Please don't write bridge, né? It's not Mandela Bridge. There must be salt in front of it. Salt bridge. Yes.
So what do we call the one that is not double? It's one, just one line, one stroke.
It's a phase separator. Sophie? All right. Yes, like Leo Valdez. She's burning up. All right, number 2. Somebody asked, who was asking me a question? I don't know if it was Nonkuleko or Sophie. Look at 9.1.2. Name 2 standard conditions that is what? Applicable. Who asked that question a while ago? I don't remember. Nonku, was it you? Yeah. Okay, do you see how it's asked now? Okay, so guys, which ones are correct here? Name 2 standard conditions. I gave you 3. Thank you, Tamron. Standard temperature and concentration. But I'm going to ask you to write it in full. So you are going to say standard temperature of 298 Kelvin and standard concentration. That's how you write your answer. Of 1 mole per dm cube. Identify the reducing agent. Please, this is important now. Identify the reducing agent. Okay, let me quickly take you through the formula page again. Something that is important that you should not forget. All right? Thank you, Sophie. Guys, on your formula page, let's quickly check one. I'm running through now. I want to be done by past on this particular one. I'm sure you guys know this formula page. Past, I hope. You know how I roll. Guys, look at this. The cathode, what happens? Reduction. At the anode, oxidation. Oxidizing agent will be reduced, and the reducing agent will be oxidized. That's how to use your formula page to guide yourself. Okay? At the cathode, reduction, and oxidizing agent will be reduced. I want you to be careful before you answer this question that brought me here. Anode, that oxidation, and reducing agent is oxidized. So this examiner says, what is the reducing agent? In case you forget, you come here and look at it. Oh, the reducing agent is what is oxidized, and that must be at the anode. Boom. You're done. You're done. You submit your paper. Tell them to mark it. Reducing agent, it's what is oxidized. All right? And that will take place at the anode. So you go back. What is oxidized? Let's check. At the anode, zinc is oxidized to zinc 2 plus. Please take note. Don't just keep writing things. You look at it. Zinc is oxidized to zinc 2 plus. All right. Everybody okay? Yeah, it's just a boom, 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 boom thing, you know? Boom, chagalaka, boom, boom. Okay. All right. So what is oxidized? Zinc. Woo, there's some free 5 marks that is just flying here right now. The initial reading on the voltmeter connected to the electrodes at the above given cell is 0.49. Let me bring the British out of me. The question was, which one is a reducing agent? Yes. Which one is a reducing agent? They are telling you that which one is oxidized. A reducing agent is oxidized and zinc is oxidized. Sophie, got it? Which one is a reducing agent? The reducing agent is oxidized. And oxidation takes place at the anode. So I just went back to the anode. Guys, do you want to get me these 5 marks? The EMF, the initial reading is 0.49. Oh, so that means this voltmeter is 0.49 volts. I'll give you, you don't need more than 2 minutes, guys. Get me element X. It's 5 marks. You don't need more than 2 minutes. And I want to time you. I really mean 2 minutes. Let's check. If you do not get it in 2 minutes, then you don't know it. Okay, let me be harsh. 2 minutes and 30 seconds. Go. Dum. Yes.
So when they ask us about to identify the reducing agent, we must tell them, we must just name the substance, or we have to tell which one is being oxidized for what, or we just write it as zinc.
Just write it as zinc. Zinc is oxidized. That's what they're asking you.
So write it as zinc is oxidized to zinc and to...
No. They just write zinc.
Okay.
Zinc. Oh, I see some people are done. They are telling me it's nickel. Wow, that took less than a minute. I don't trust these people with these answers. Tamron and Nonkuleko, the two of them, I don't trust them. Can other people tell me that they are wrong? I want people to tell me that they are wrong so we can rub it in their face. Mordecai and Rigby, in your face. They're right. Jeez. So it's in my face, not their face. Even Zanele says nickel. In my face. Mordecai and Rigby. I'm a fan of regular show. Come and talk to me. Is there anyone who's disputing that it's nickel? You're not sure? Please let me know. Otherwise, we just move on. It's 5 marks, guys. I mean, like really now? 5 marks? It's 5 marks because it's 5 marks. Tamron, it's 5 marks because it's 5 marks. I'm telling you. It's 5 marks because it's just 5 marks. That's how it is. This is how we do it. Bum, 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 bum. So this is what I'll do for 5 marks. I have 11 seconds to do it. I can't finish. Now, you write the formula in full. It's 0.49. Do we know the cathode? Which one is the cathode, by the way? The cathode is X, okay? And the anode is zinc. So I do not know the cathode. Minus, what is zinc? Give me the value for zinc, everybody. Somebody give me the value for zinc.
-0.76.
Thank you. Negative 0.76. Now you do the maths. Bring that over. Okay, this is plus. When you bring it over, it becomes negative. So it's negative 0.76 plus 0.49, and that is the E value at the cathode. And your E cathode would be what? Negative 0.27, right? Therefore, X is silver. No, you said nickel. Sorry. All right, done. 5 marks. 1, 2, 3, 4, and 5. All right. Let's move on. Write a balanced equation for the net reaction that takes place in the cell. Do you see it's 3 marks? Leave out the spectator ions. Now we know we are dealing with nickel and zinc. That's easy now. Cell, do you want to do that balancing? Take over and do the balancing. Let's check 3 marks quickly. Nickel and zinc. Zinc is zinc is oxidized. It's at the top, right? Remember? Z. This is where you use the Z. Okay, I won't do all the little nitty-gritties again. Now you know what to do. You know what to do. It's A, N, C. This is what you have on your table. Zinc 2 plus 2E to give you zinc. And then you have nickel. Nickel is 2 plus, I think, right? So you just follow the arrows. Follow the arrows, guys. Follow the arrows. So you start by writing the anode. We're starting from the right, going to the left. And then we talk about the cathode. We start from nickel plus 2E to give us. Please take note. Do not write double arrows. Now, what I notice is that my electrons are the same in terms of number. It's 2E. I don't need to multiply this time around. It's 2E, 2E. So what do I have? Zinc plus, I'm making a mistake here. This is 2 plus. All right. Zinc plus nickel 2 plus to give us zinc 2 plus nickel. All right. Solid, aqueous, and solid. 3 marks. Guys, are we okay with the 3 marks? Everybody okay with the 3 marks? Everybody okay? Talk to me. I need us to move very fast now. You get your 3 marks there. Don't you see 100% in this question already? Don't you see your 3 marks already here? Talk to me. Don't you see your 100%? It's staring you in the face. Staring you in the face. All right. Guys, let's quickly talk about what are spectator ions. Just somebody's wondering, when they say spectator ions, are we watching soccer here? What are spectator ions? Somebody. When they say spectator ions, what do they mean? What do they really mean? When they refer to what do they mean by spectator ions? Should they ask, how would you respond to that?
Please go back to the last slide.
Which slide?
The previous one. No.
Where we did the calculation?
Yes. Okay, it's fine. Thank you.
Okay. Now, guys, what are spectator ions?
Ions which do not chemically participate in a reaction.
All right. They are species that do not chemically participate in the reaction. Thank you so much, Nanku. That's a very, very good answer. All right. Now, let's answer the next one. How will the initial voltmeter reading be influenced if the 2 metal plates are replaced by metal plates that have a larger surface area? This is not a common question, okay? But let's answer. The 2 metal plates are now changed and they have a larger surface area. Look quickly here. I'll answer this. The answer is increase. They will increase. Okay. Oh, Brown gave me an answer. They will increase. The question is, why will they increase? Let me quickly explain why they would increase. Now, guys, when I have that there, we say that the standard concentration here is 1 mole per dm cube. But if I use something with a larger surface area, remember what happens. Oxidation takes place. So the metal ionizes into the solution to increase the positive ion concentration. Which means this thing is no longer 1 mole per dm cube. It will no longer be 1. For example, we said zinc, right? So I have concentration of 1 mole per dm cube, zinc salt. But because of the larger surface area, more electrons or zinc, the rate at which zinc oxidizes will increase, such that this concentration will be greater than 1 mole per dm cube. And if that is the case, the E cell value will also what? Increase. I hope that makes sense. The larger the plate of the surface area, the higher the E value of the whole cell, because more the rate of oxidation will increase. I hope that makes sense. Therefore, the concentration of the electrolyte will also change. Okay. I'll explain something while I'm on this right now. I'll explain something here. And that is applicable. I think the next one is silver. Let me check something. I think it's silver. No. All right. Look at this. Let me just do it here. Should I have silver? Watch this. Silver is always a very good explanation on this. Should I have silver in one of the cells? I don't know what I have on the other side. Okay. Should I have silver? An examiner would say that drops of maybe hydrochloric acid was added to this. The main thing is the chloride. Please listen carefully now. The main thing is the chloride. Sophia, I would not forget. All right? Now, HCl. If I add HCl to this, I will automatically form silver chloride. And silver chloride is insoluble. Please, every time you talk about silver in electrochemistry, please always refer to silver nitrate. Please take note. Every time silver chloride is not soluble, please. So you cannot use it as an electrolyte. So every time we refer to silver, please always use silver nitrate. So an examiner says we add HCl to this. What do we form? We form AgCl, which is insoluble. What does that mean? It means the concentration of our silver nitrate salt will then decrease. Please take note of the sequence. If I add any Cl to it, whether HCl, I can even add NaCl, anything that has a Cl, I will be forming silver chloride. And when that happens, because it's insoluble, this is called contamination. All right, we form silver nitrate. We form silver chloride. The silver nitrate concentration will decrease. How will this affect E cell? Please listen to this. E cell. Remember, please don't write short forms. It's cathode minus E what? Anode. And write that there. Watch this. Let me use numbers. If this is 20 equals to 10, no, other way around. If 10, let's use 15. 15 equals to 20 minus 5. Please watch this. If I increase the cathode to 25, what will happen to the E cell? Will it increase or decrease? I want you to learn to use numbers to find your way. Good. It will increase. Thank you so much. Thank you very much. You guys are the best. Beautiful. Now, what will increase the cathode will be an increase in concentration. So if I increase concentration of the cathode, the E value will go up. If the E value of the cathode goes up, the E cell would come down. Let's do the next one. If I were to increase the anode to 10, what would happen to the E cell? The E cell will decrease, right? Good. So if the E anode increases, what happens to the E cell? It will decrease. I hope it makes sense, guys. And what affects the values are concentration. So if concentration increases, the E cathode or the E anode will increase. And if that happens, it affects your EMF. They are not common questions, but no, it does threaten learners of the 1-2 marks. Okay. All right, guys, I want to finish. So if you don't worry, I got you. This is where I'm going to, the reason why I'm saying don't panic is I'm going to answer your question here. Okay. So relax, baby girl. Write down the value of the reading on the voltmeter when the cell reaches equilibrium. Oh, this is simple. When the cell reaches equilibrium, it is 0 volts. And we call this a flat cell. We call it a flat cell. All right. Thank you, Zanelli. 0 volt, flat cell. And basically, a question they'll ask you is to use Le Chatelier's principle to explain that. If it's a flat cell, let's see quickly. Do I have space here? What is a flat cell? Flat cell, the E cell is equal to 0. You are simply saying the rate of oxidation of zinc is the same. Guys, remember, I'm using the rate, chemical equilibrium. Is the same as the rate of reduction. Now, nickel is not reduced of nickel ions. Please take note. Nickel ions are the ones that are reduced. All right, I'm done with that question. I want to believe everybody's okay. That's your galvanic cell. That is your galvanic cell. Quickly. Please talk to me, even those who want to be quiet. Talk to me. I want us to go through another question that is a bit different from here. All right, beautiful. I'm getting all the lovely okays. Okay, look at this one. Look at this one. So we'll answer this one and then we'll move to electrolytic cell. But I want to be confident that we're getting all the marks. Thank you so much, people. I love it when you say okay. All right. Is this visible to you? Or should I do my thing? The standard potential produced by a voltaic cell consisting of a platinum electrode is in contact with the solution of cobalt ions, and the silver electrode in contact with that is 1,01. Let's read again. The standard cell potential produced by a voltaic cell consisting of a platinum electrode in contact with cobalt ions. All right, so this is what the examiner has done. Examiner has put cobalt ions here, and they said this is platinum. Why platinum? We would see just now. Silver with silver ions. The EMF of this cell is 1,01 volts. Okay. Write down the cell notation of the reaction. Beautiful. Guys, do you want to tell me which one is the anode and which one is the cathode quickly? Anode and cathode. Which one is the anode and which one is the cathode? Quickly, everybody. 4B, table 4B. Let me help you here quickly. Guys, don't look for platinum, please. You are looking for cobalt and silver. You are looking for CO3 plus and silver, not platinum. Platinum is an inert electrode. Platinum is an inert electrode. Tamron, platinum is inert. I'll tell you why when we use inert. This was the question that Sophie has been asking. It's time to answer her and every other person. When do we use platinum? One, when you have a gas. 2, when you have a non-conductor. When you have a gas and when you have a non-conductor. So this time around, the examiner decides they don't want to use cobalt metal or cobalt solid. They want to use cobalt ions with a platinum inside. So what do we then do? Write down the cell notation. So let's go check together silver and cobalt quickly. CO3 plus. Please take note, we're looking for CO3 plus. Where is it? All right, we go down. That's chromium. This is cobalt 2 plus. Okay.
So take the last one, sir.
Huh?
Take the last one.
Second, good. I want us to go somewhere. So check. This is why they are using cobalt. I want you to see that. Do you see that this CO3 plus? We have CO3 plus, thank you so much, plus E. This is what we have. It doesn't give us a solid. It's not a solid. It doesn't give us a solid. That's why we are now using platinum. Please, I hope we're okay. We use platinum because it is a solid, it is inert, and it's a conductor. Solid, 3 reasons. Solid, inert, and conductor. So this time around, we are using platinum because the cobalt that we are using, it only changes from cobalt 3 plus to cobalt 2 plus. I hope it's making sense. It's changing from cobalt 3 plus because they gave us 3 plus to cobalt 2 plus. Okay? All right. If they had given us cobalt 2 plus, then we wouldn't need platinum because cobalt 2 plus, you see, there, gives us cobalt. But now, they are not giving us cobalt 2 plus, they're giving us 3 plus, which gains an electron to become cobalt 2 plus. And it must be, the electrode must be a solid, electric rod must be a solid. All right. So we all agree that silver is oxidized. Silver is oxidized. I think after answering this question, no one should have issues. This particular one. Okay, so silver is oxidized. And cobalt is what? Reduced. Now, what will my half reaction look like? Please take note. I start with the anode, remember? So it's going to be Ag, solid, Ag plus, aqueous, that's oxidation. Everybody should be okay now. I have skipped steps because I know you can go back and check this. Now, reduction. It's CO3 plus, which is aqueous. And on that table, we have CO2 plus. I hope you understand that. If I were to write my half reactions, that's what I would have written. All right. And now I have a platinum solid. You must always write that platinum. And that's your half reactions. Do you notice this is aqueous and aqueous? They are of the same phase. There is no stroke between them. Please let me know if you got this. If you got this, then I'm good this afternoon. I am all good. First is the anode. My advice would be, write down the half reactions first. Okay. Write down the half reactions first. And I'm not putting a phase change because it's both ions. The phase change comes after platinum. All right, which is a solid. Okay, I'm glad. So we're done with our cell notation. Identify the oxidizing agent. When they say oxidizing agent, what is the examiner referring to? Examiner is talking about what is reduced. Which one is reduced? That is reduced to that. So it's cobalt 3 plus ions. Write down the reduction half cell. Easy. Easy. I'm sure you see where I got that from, right? Thank you. So, guys, are we okay with this 5 marks? Easy stuff now. I'm moving on fast. I'm staying so long here because most of us said we didn't do electrochemistry. I think right now might not be perfect, but a lot better than when we came into class today, I guess. The way References said, oh yes, I could feel the yes. Even times were definite, like I could feel the oh yes. She just said, oh yeah. All right. Let's look at this. I call this she. This cell is called she. I have a song on this as well. She. Beautiful song. Although the video is not ready. I call this she. Standard hydrogen electrode. The song is very romantic. Okay. It's she because we're talking about a beautiful African queen. She. That's what the title of the song is. But it's basically standard hydrogen electrode. She. Okay? You want me to send the audios? You won't enjoy the audios. They're nicer when they are in videos. Okay, but I'll see. I'll see what I can do later today. All right, an unknown metal M is connected to a hydrogen half cell. Now, the question is, what is the purpose of she? What does she does? She is used to measure the electrode potential of all the species. So, guys, all the values you see on your table, you'll imagine the video. Okay, I'll send them. I'll send them. All right. So all the values you see on your table, when we go and check all those values, basically is measured against hydrogen. That is why when you check hydrogen, hydrogen is 0. Everybody, please check your table and look for the value of hydrogen on that table. Tell me if you found it and it's 0. If it's not 0, please let me know. Oh, even in KZN, it's 0, right? I want to be on. I want Nduduzi to be on your cases, guys. We must transfer Nduduzi to KZN. It's always on their case. All right. So you see, it's 0. KZN is my home, guys. I might be coming to KZN in 2 weeks' time during the holiday. I might be teaching in KZN for the week. All right. Okay. I'm not sure yet. I'm not sure. If you want me to come, talk to your principal. Let your principal give me a call. I do come. I'll visit your school, and you'd host me for the week. Just tell your principal. Ladies Smith Secondary School, right? Yeah. Tell your principal to give me a shout and organize for Crazy Physics to come. Okay. But I know I might be in Mpangeni and some other schools for a week, 5 days. I can't just rock up. I must be invited. I'm a special guest, Okay, anyway, we'll talk about that. Money, 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 All right. She is used to measure the electrode potential of other species. So let's understand what she does. What happens is, you see, now we are connecting M to hydrogen. Whatever the reading is here is what we find on the table. I hope it makes sense. Whatever the reading is here is what is written on the table. For example, we got negative 0.027 for silver, no, for nickel. That means when we connect nickel here, the value is that. Yes, or 0.27. Yep.
By other species, what do you refer to? I mean, like, I got a question here that says name of the species that acts as a reducing agent, and the species kind of confuses me.
Okay, do you want to quickly send it to me on WhatsApp?
Okay.
Thank you very much. Then I can project it and we all look at it together. All right. Okay, guys. What is the purpose of standard hydrogen half cell? It is to measure the electrode potential of other species. Name the metal labeled X in the hydrogen half cell. Guys, hydrogen is a gas. Do you want to tell me this metal? What is that metal? What is that metal? Thank you. Platinum. All right. Nonkuleko received. Just going to look at it. That metal is what? Platinum. Okay. Lovely. State one function of the component labeled A. Fatrab, why? You said why? Okay. Zanile also said why. Please ask your question in full. Why what? Fatrab, why is it platinum? Guys, I did mention that anytime we use a gas, let me take you back. Anytime we use a gas or a non-conductor, we use platinum. Why platinum? Platinum, any gas or anything that does not conduct. Why? Why platinum? Platinum is inert. It is a conductor. And it is a solid. Inert means it will not react. So anytime we have a gas or something that will not conduct electricity, all right, we use platinum. Inert, conductor, and solid. They might ask you all of those. All right, why platinum as a choice? It is inert, it's a conductor, and it's a solid. So take note of that. So I guess that's sorted, right? All right, state one function of, okay, I see answers are coming in. Complete the circuit, maintain electrical neutrality in the half cells. Beautiful. Guys, please identify M. The reading on the voltmeter is 0.74. Please identify M. Reading on the voltmeter is 0.74. Please identify M. Got it. What is M? Thank you. You guys are correct. Chromium, Cr. Beautiful. Guys, can you see that this is easy? Use information from the table of standard reduction to write the overall balanced redox reaction. I think that's straightforward now, guys. Since we know this is Cr. And which one is my anode? Which one is the anode? Which one is the cathode? Talk to me. Which one is the anode? And which one is the cathode? Let's do this fast. Which one is the anode and which one is the cathode? So Cr is on top, right? Good. Are you sure, Mutise? Which table are you using? Make sure it's 4B. All right. Good. That's a very costly one there. I almost jumped. Okay. So Cr is my anode. That's the anode half cell. That's the cathode. I'm sure you know what to do, right? We write the anode from the right going to the left. Anode would be what? Cr to Cr3 plus 3E. We write the cathode, you know what I'm saying, talking about, from the left to the right. Because hydrogen gas, let's check, will be reduced. All right, so we write it from the left. Sorry, hydrogen ion will be reduced to hydrogen gas. We write it from the left to the right. So it is 2H plus E to give us what? H2. It should be 2E. Okay, guys, do you want to balance this for me quickly? Balance it. You balance it for me quickly. Net ionic equation. Uncle Leko, you sent me 2014. Okay, I think I do have a copy. I'm going to crop this question when we get to electrolytic.